Hello, welcome back to Blender Sushi LiveENODING. In this episode, I'm gonna show you like a quick setup. You can use Sverchok Add-On inside Blender to interpolate from triangle to a circle. And this is actually something that was inspired by this circle morphing with Golan Levin. Is the guest star of this coding train Daniel Shiffman. So if you look at the video and then have a look at how he explained, he has many ways to convert triangles to circles. There are actually multiple ways to do this using Sverchok, and you already have all the tools, all the nodes to do this. So it's gonna be pretty simple and basics. So anyway, let's get started and start with a fresh Blender. Delete everything, file, save as, and save this as triangle circle demo, and go to compositing. So let's get started. Go to the top view. We're gonna use a circle node and gonna use the viewer draw. So we got a circle by default, but if you reduce this to 3, you get a triangle, and the triangle is pointing at the x-axis. And the idea is really to cut every edge of this triangle and then resample it the same number of points to the circle. So if we have like a triangle and we separate the edges, we can also do the same for a circle, separate it into 3 edges, and then we just simply do the vector lerp to interpolate between the two. As long the number of points of the edges are the same, then we are fine. So yeah, let's get started. Let's do this. With this triangle, we can use polygon boom, basically to separate every edges. So this is the first thing to do. And for each and every edges here, we can use vector interpolations, basically, and use a range float between 0 and 1 to interpolate the edges. So, and we can use UV connections to connect all these points together. If I bake it, you will see that we get this. Supposedly we get a triangles with 3 edges. Okay, I need to turn this into edges. Bake it again. So we have 1, 2, 3, and for every edges we have the same number of points, which is 10. So the points at the corner here are overlapping. Okay, so this is the first thing to do. So we have the triangles. The next thing we want to do is to have a circle, another circle, and let's give it a color reddish. So by default, we get a circle, and I think I'm gonna make this 30, and I will try to cut it in the same way that the triangle. So since we have 3 edges, we want to probably have it something like this, and number of vertices 10, and yeah, this is actually how I will do it. There are many ways to do this, and I have a couple of ways using nodes in Sverchok to do this, but this seems to be the simplest. So I'm gonna use, if I use just a UV connection, I believe I should get the result right away. So just, we have 10 points to create a circle, and that's exactly what we need. So matrix apply, or matrix Euler, and apply matrix, or we can actually use rotate, I believe. So rotations and Euler, the idea is to rotate this points 3 times. So in maybe list input, so you can, the fact that you can do this thing is actually really cool. So we have 3 angle, 3 values to represent the angle coming into these rotations, and as a result we have 3 data that we can use to create our triangle to circle interpolations. So if we use just a UV connection over here, we should have our circle back. If we bake it, we have 1, 2, 3 edges to represent our circle. And if we bake the triangle one, we also have 3 edges to represent our triangle. So delete everything, and now let's do the magic. This is where it's happening. Use vector lerp and simply use the vertices from this guy and this guy, and use UV connection, and hopefully this is working as planned. So this is going to be green color, and let's have a look. Interpolate. So we have triangle, circle, and let's use the edges as well. So let's do the interpolations. Triangles, circle, triangle, so circle. So that's cool. So that's working really well. And if we want to make this like fully procedural setup where we can make changes to the circle, like making it like instead of triangles we want maybe like 5-sided or 6-sided, we can do the same thing. We just need to have a little bit of math somewhere here. So this is gonna be an extra additional bonus for this tutorial. So currently we have 3-sided triangles, of course, 3 n-gon, and then we have a circle. Circle is made of 360 angle, so we need to, let's see, divide. So 360 divided by 3, we have 120. 120 goes in here. The number of vertices interpolations coming from this guy up here is also important. So 10. So we have the circle, and the radius we can leave it. And what else? This list input, we need to have something like that. Range float, I think will work. The step will be coming from this angle, and the count will be coming from this guy right here. So if we check with the stethoscope, this range float is generating a value that's the same as this guy right here. So we can cut this, simply use this guy, and as a result we still have the interpolations happening. Triangles, circle, cool. So let's see if we change this, what's gonna happen. Hexagon, it's just, what is this? Hexagon, polygon, I forgot the name of 5, n-gon. But we have this ability to do this, which is really cool. And if you like to do further with the vector here, we can actually use a sine wave. If I'm not wrong, we can also kind of extrapolate this vector, if I'm not wrong. So if we use like a math, we can go over and we get a flower or a star. Flower or star, or circle or triangle. So this is, I guess, a pretty cool setup that you can play around with. Let's go back to triangles, and we can leave everything else as it is. So I call this triangle circle. So in about 10 minutes we already get something that's pretty cool looking, and perhaps I'll bake this to see the process. So we have the oops, we actually have a separate objects, but if you like we can also join it, mesh join. So a lot of lots of really cool nodes already. Bake it. So we have triangle, and if we lerp it, we have this interesting, like a fat looking triangles, and here we have a circle. If we continue extrapolate it, we have this like a flower looking view, top view, and if we go the opposite we get like a star. So yeah, this is all about interpolations, extrapolations, a lot of interesting thing happenings thanks to vector lerp, a lot of UV connections. So a lot of this just like a logical, all the nodes is already there since many years ago, like when Sverchok was still being developed, and this is one way you can use it. So yeah, hopefully you find this useful and interesting. Let me know what you think, and I'll see you next time. Thank you. Bye.